Thanks very much. And I would like to start with acknowledging to our First Nation people and the country that we are on today and meeting today, but also to the elders, both past and present, and extending that to all Aboriginal and Torres Strait Islanders on the country that we work on. And in particular, I'd like to, at the Mulloon project, we are on Yuin country, but we're also on the boundary of where there's 4 tribal areas. In fact, it's also, as Uncle M, and I can't mention his name because we've lost that elder recently, and so respectfully we won't mention his name, but we're in message stick country, with sharing with Ngunnawal, Gundungurra and Ngarigo country. Anyway, without further ado, some of you may not be familiar with the work that we do at the Mulloon project, just east of Canberra, just the other side of the Great Dividing Range. We are in a catchment that feeds 5% of Sydney's water catchment. But this is what Mulloon Creek looked like in the 70s. And our founder, or founders, Mr. and Mrs. Tony Coote, unfortunately we have also lost them more recently, but they've bequeathed these properties. But they started this pilot project, this idea of rehydrating the landscape. And what you can see there is a stark contrast to what Mulloon Creek was. And that's a pretty good example of Mulloon Creek, highly incised, degraded landscape. And with that, a drying landscape, because not only our long-term landholders in the area, but even our First Nation people noted how it used to be a highly productive, lots of water around the area, and yet it was dried out, desiccated and sick in their view. So, a quick overview. This is what, in 5 years' time, from when we implemented this pilot project in 06-07 to about 2012, we could see that there was greater than 60% increase in productivity on the floodplains. Now, generally speaking, your productivity is always going to be tied to water, but I'm going to be talking a lot about biodiversity here. So there was a whole heap of other benefits from a production farm operation point of view. But really what we're talking about here is that this greatly increased our vegetation, whether for production point of view or for environmental. And our biodiversity, that also was a co-benefit. We like to look at it that actually it's not just a co-benefit, it's a major benefit. And production was also being supported by that. We heard that in that previous talk too, with many other benefits in terms of the environmental, either from an insect pollination point of view or predatory species. But particularly another key factor was that we've now created a microclimate. We've moderated that landscape. Every plant is a biotic pump that is basically an air conditioning system. It is nature's most efficient air conditioning system if we talk about climate change and a heating environment. So just to give you a visual representation for those of you who haven't had the pleasure of coming out to Mulloon Creek on one of our field days, this is an example of how we've rehydrated, and this is often where we bring people to Peter's Pond, and you can see a very incised creek. You can actually see on the right-hand side a gravel bar, and the size of the cobble there shows you the energy in that waterway and the amount of material that was being moved down through the system out of Talaganda National Park and through into the Shoalhaven. And yet, with some very good modification, and yes, I'll have a talk to Stefan about, but sometimes you need to intervene with a bit of machinery to try and stop the bleeding. And by doing that, what we're doing is, to some degree, some level of bioengineering. And here's another great example. Many of these leaky weirs, as we commonly refer to them, or stream bed erosion control structures, sometimes they're paired up, but they're actually strategically placed where there's a step in the landscape. So this is where I feel that we are very similar to our First Nation people. We teach people how to read the landscape, how to understand how water moves through the landscape, and not just water overland, but particularly picking up even features of where water flows subsurface, because the two are interconnected. And particularly, as I'll try and explain to you, Australia's landscape has adapted very well that the most efficient place to store water in this Australian landscape is subsurface. And you can store a huge amount of water that will carry you through the dry periods. In particular, what we noted was that when we were doing this project, we went through this extreme dry, and our floodplain pocket that last recharged in 2016 was still delivering water out through the creek at the back end of that extreme drought in 2019, when there was still no water coming in from the top side. So that water had to be coming from somewhere, and it was coming from the recharge stored in our groundwater aquifers. And so what happened was our downstream neighbours were able to benefit from that because water still continued down through the waterway. And so it was interesting how, at that time when we were doing this pilot project, a number of the landholders were really up in arms about it, very against it, that they thought that Mr. and Mrs. Tony Coote was going to steal their water. And yet now those people, once they saw those benefits through the back end of the millennial drought, mind you, that they have now become our biggest supporters. And driven by that now this is actually a project that is more or less, it is driven by that landholder push. Even the catchment next to us in the sandhills basically demanded to be involved. So this project actually expanded to involve not only the Mulloon Creek, but you can see that one up on the top left there of Sandhills, which is also still flows into Mulloon Creek. That actually epitomised what these projects are really about. They're a social community project. But that's not what I'm here to talk about. It's going to be about biodiversity, I assure you. But it is how landholders are a major driver, and at a catchment scale, this is where you can get the greatest value. A farmer can do it on their own and get their own benefits, but as I've indicated, even downstream you also get these benefits. But if you really want to see a major benefit that actually manages your small water cycle, which actually influences climate, draws in more rainfall, more regular rainfall, rather than extreme rainfall, you can actually affect your local climate through this by managing your water, and particularly your local water cycle. So we then roll this out down through the other catchments, and here's some other visual examples, because people go, oh, well, that's a fairly different change in time. Keep in mind, all of these structures were being put in during the absolute extreme drought, more extreme than millennial drought. And what we've got here is that you've got almost an instant response, that even in the smallest little bit of rainfall in the middle of the drought, you can get regeneration. This is one of, all these examples are wonderful, but I can tell you that there's an example of a 2019 photo in between of this where half that veg has already come back 6 months later of being implemented. This vegetation really does respond quite well sometimes, and particularly already this is adding a filtering effect that has already improved your water quality in terms of turbidity, it's shading it, temperature of the water, and you know what, best of all, it's already creating habitat. You can see how dry it was on the left-hand side photo. It was desiccated. This is the extreme end of the drought now, 2019. And yet those very first rains we had in March, there's fires raging all around us up until then. But the first of the fires are starting to be put out now with that little bit of rain, but already you can see the response. Then we got hit by a flood, 1 in 50-year event, one in 2020. And you can see the fluvial patterns. We've actually reconnected our creek with our floodplains. Why? Because those leaky weirs, what they're doing is they're de-energising that water, slowing it down, dropping that sediment out, and you're actually causing that water to spill out over the bank, de-energising it. You're taking that power out of the water and you're spreading that out. And what we did note was Peter Hazel and all his team out there doing all these on-ground works, that we actually benefited, sadly, from the loss of all that soil erosion up in Talaganda and all the organic matter tipped out in here. And I know I'm going to be running short on. So we've got a whole heap of monitoring that we do. We've got hydrological monitoring, we've got climate stations. We are monitoring flora and fauna right across this area. And I'd like to put a big shout out to Hydroterra, our partner in Melbourne, who manages our data. It's very important that this is managed really well so that we have scientific credibility. And you can see here also that these are all our rapid assessment and riparian condition sites that also double as our frog sites and our bird monitoring sites. And we call upon a number of people to help us. But Key things are that our downstream users hydrologically were not, in fact, they got positive benefits. Our water quality improved. Total volume has not diminished. It's actually delivered over a longer period of time. In fact, we find that because of also even that diurnal effect of dew, besides the water we've stored in the groundwater, that we're actually drawing in more moisture more regularly. We've actually created a microclimate in this valley that actually draws in more moisture and more regular rainfall. So we've actually reconnected not only the floodplains with the creek, but we're actually positively affecting our local small water cycle. And this is what I do, a call out to all you catchments out there, that this is similar, that you can do in your own areas. Rapid assessment and riparian condition, really good results already. Particularly draw your attention to the fact that in these 5 years, prior to any leaky weirs going out in this rollout, during the drought, and then into 2021, we've had an increase particularly in habitat, cover and natives. Even though we've had all those increases, and you can see that there's still a little bit of, some sites haven't improved. Why? Because only 2/3 of these sites have even had leaky weirs. So we're still yet to see the full benefit come out in this. Frogs, excellent results. We've actually seen our frog species and numbers and our average frog numbers per site increase over the period of time. So those green squares on the left are showing you where the highest frequency was detected. Now that's bucking the trend for the fact that the Southern Tablelands or ACT Frog Watch are saying frog numbers are in decline. Our dam and wetland sites, a similar story. Shout out to Sam Patmore, who helps us with all of that. Fish surveys, well, we also catch some eels too. I had a great time picking up that large fin eel. But what I really want to show you here is that our latest survey has indicated that our galaxids are on the increase. But have a look on that right-hand table. You'll note that there's a blank in the 2016 for the mosquito fish, Holbrookii, for sites 1 and 2. Interestingly, that's the pilot project. So we'd like to say that in due course, we want to see that as we've rolled this out, the Holbrookii mosquito fish has disappeared due to the fact that we've reinstated the natural processes that actually promote our native fish species and other predatory species as well, and that the invasive species are naturally being pushed out. Only two were found in our catchment. So we're really looking forward to what's going to happen in our next survey. Birds, wonderful result. I mean, birds are really seasonal and migratory, but the key points to this is that we've got 7 rare and declining species and 4 threatened species that are noted in this area. Damon Oliver for New South Wales OEH kindly obliges us with his time and effort, and he's looking forward to getting back out. COVID put a dent in that and he wasn't allowed out, but hopefully he can come out and play with us soon again. But what I really want to note is that during that really extreme drought period, the rare red-capped robin, which usually occurs west of the Great Dividing Range, was noted in ours on the eastern side of the Great Divide. It's because it was looking for food and habitat and water, the basics of life. And we had that in spades. We also attracted many feral pigs as well. And given the fact that I have a whole heap of other satellite imagery and stuff as well that would show you that we were actually increasing our vegetation cover. We always were maintaining close to 100% veg cover, and I agree with Kate from previously before. That is a key to protecting your soil, because your soil is your key component, whether you're doing it from an environmental or production point of view. And if you think that all we do is leaky weirs on contours, on floodplains, I'd like to say that there's another whole story here with leaky weirs or leaky contours on the ridge lines, and rehydration needs to start from the ridge line all the way through to your waterways, because you need to rehydrate all of that country. And what we do here is, again, teaching people how to read the landscape, where these natural formations are, where you would put a leaky contour, where what we're trying to do is we're trying to slow that water down, number one, and then we're trying to spread that water laterally so that we can actually hydrate everything down slope, and gravity will actually feed that down naturally for you. Now take a note on the left-hand side, that was just soon after it was built. We put in some trees, you can see some tree guards there. Have a look at the tree growth there. Again, remembering this was done at the back end, 2018, 2019 and early 2020 extreme drought conditions. Now, hats off to Max and Pete and the other team and the rest of the people who planted these trees. They've obviously got a very good skill at it. But what is of interest is the wetland species around that now perched wetland that we've created. We didn't plant any of that. That has naturally occurred. Now, argument could be is that those seeds were always there, waiting for the right conditions, because this is perched wetlands were and often a feature in this country. This is just a step off the Great Dividing Range, keep in mind. Or animals have brought that seed in. Either way, nature is recognised. Plants will grow when you actually, especially native plants, when you get the conditions right again. And part of that is the whole soil, water, plant triangle, integrated systems management thinking. And there's another view of it. That's what was planted out in 2018, and we've now got a virtual forest. Now, what has happened here now is that not only have we got habitat, but it's actually created a cooling effect. We've now created so much hydration there that we've grown so much vegetation, the ground now feels spongy again. And that's how you know that your soil is working, because it should feel spongy. Even up on the Great Dividing Range, where that soil is best maybe 0.5 metre in profile before you hit rock. And yet we've got more vegetation there. It's still being hammered by resident 1,000 head of kangaroos as well as deer, and yet they're not keeping up with it, whereas before it used to just get grazed to the ground. And we've taken many people there, and I'm hoping, Penny, you're going to be bringing yourself and Sue Besto out there very soon to join us to come and have a look at this firsthand, because this is where your productivity starts, but most importantly, this is where you start managing your water. And you need to be able to manage your water as a primary aspect, because water is what is going to drive your small water cycle, and managing it in a way that you can promote vegetation growth that protects your soil. And in doing so, you're actually then starting the process of getting microbial activity, which will then rebuild your soil, physical, chemical and biological components. And that is going to be the drawdown that you need. So the call to action. Landscape rehydration is fundamental in a country that is the most, let's say, the driest inhabited continent on Earth. And so it is fundamental to our lifestyle, and our First Nation people that we've worked with agree with it, that dehydrated is one of those sicknesses that we have in our country, from Northern Australia to Central Australia, even to the Southern Temperates. And so we need to address our small water cycle, because you know what? Our carbon and nitrogen cycle as a symptom is also broken. And we concentrate and focus on carbon, and it is true, we need to deal with less burning of fossil fuels, better recycling of our waste and waste products. But it's our water cycle that is the bigger cycle that drives this system. And carbon and nitrogen cycles are part of that. They are symptoms of that. And our waterways, if you think of it, they're our veins throughout the corridor. So if we actually ask our landholders to look at it, that it's your waterways, that we need to put a buffer on that to stop your country losing resources. Because once that surface overflow takes your resources away, you've lost that resource off your farm, and it's travelling down, and it's causing turbidity. It's causing problems to the Great Barrier Reef. Our projects up in the far north Queensland that Sam and Joe are doing would reduce turbidity and sediment load on the Great Barrier Reef by 95%. A good success. And we'd like to be able to roll that out more than just some demonstration projects, but similarly even at Mulloon here. Because water is life, but as we've seen, water can also be highly destructive with floods. And so from that point of view, I'd like to say that integrated land management is the key to our repair and regeneration of our landscape function. And from using the classic word of the conference, the community subsidiarity is the main aspect of where the Landcare network is already there in place, and it has been a major conduit for reaching out to us, whether it's through running workshops, bringing you to Mulloon to do a demonstration, show you what we're doing. But in many cases, we want to be able to actually demonstrate that and work with you in your own local community. And I agree that you have your local champions, but equally, I want to get those people that, maybe are questioning it, to really have a go at it. And what I leave them with is, pick your worst paddock and try rehydration works that we can train you in. And we've got people like Tam, who's developed a whole education curriculum from schools right up to our landholders in particular. Well, that's the sort of stuff where we can teach you how to do that, but at the same token, we're happy to work with you. We're not here to say we've got a solution for you where you've got to follow A, B, and C. We work with you to understand what is your challenges that are specific to your region, and how do we adapt these principles to suit your landscape, your climate, and ultimately whether or not you want farming or environmental outcomes. And I'd agree with Kate before that really the two need to go together, because your environmental outcomes will greatly enhance and do a lot of free work for you for your production gains. Thank you very much. I should finish with, these are just some of an example. This map's already out of date, but this is an example of the projects that we're doing already around Australia.
Thank you, Luke. Stay up there and we'll get some questions from the audience. So anybody online can submit questions, but we'll start off from the room.
There we go, I can hear something now.
Hello? There we go. I understand you can't just go putting weirs in wherever you want, and I know you've called it a leaky weir. One of the first pictures didn't look that leaky. What are the rules around what you can put in and how high you can go and that sort of thing? Good
questions. Generally, we're looking to use natural products that are nearby, and it's usually rocks and logs. They are leaky, water will sieve through it. We don't want it pouring through. We certainly want it to be a filtering process, but it's also an aeration process by using the riffle zone as well. So it's really to slow the water down, not to stop it, but it does leak. And if anything, the biology takes over, and that's why we call them bioengineering structures, because largely they become a system that are self-repairing, self-maintaining, because the biology drives it. In fact, this is how these systems used to work. There used to be enough vegetation in the riparian that you would get these, you could call them equivalent to beaver dams, only that we've removed a lot of the vegetation, so the source material is gone. So this is why we have to, I suppose, in many cases, intervene. But once you've done that, the native vegetation really takes off, and then it starts to self-repair and self-replenish.
I come from an area in Australia where there's already a large amount of interest in the concept of leaky weirs. One of the challenges that Landcare faces, though, is the water licensing authorities that do perceive these as dams, not leaky weirs.
Yeah.
And so to actually get the appropriate permissions, it's a big challenge for Landcare to do that. So is the Mulloon Institute in a position where they can, for lack of a better word, sort of lobby on behalf of Landcare to the water authorities to help, I guess, establish a process that they can get permission to put these in?
It's a great question. You're very right. We can get caught up in doing controlled activity approvals, for example, even in this system, and we are caught up with it at the moment. Controlled activity approvals where it then needs a DA because we're in Crown land and we've been, let's say, buried in paperwork. So even before that, Pete Hazel would say a general idea would be is that without going through a full DA, 9 months to do a controlled activity approval, from planning to submission to approval to green light, and yet that might be for one, and that's done on a property by property basis, not a catchment. And it might be for the equivalent of 12 or 10 leaky weirs, and in 3 weeks we're done with the on-ground works. So you're right. So to answer your question, we are currently engaging with the New South Wales statutory requirements through our law committee led by Matt Edgerton-Warburton and some other very environmental law people who are giving their time for free. And we currently have got legislation in front of them to look at a different alternative. And that's not to say to get rid of regulatory, it's just to say rather than demanding a full DA, that we go down this pathway so that because it's proven that, well, what we're trying to prove is that we're actually doing it from not a development point of view, but we're actually trying to fix the system that's going to have a benefit to that. And there's a lot more that my CEO here, Carolyn Hall, would be able to fill you in on that for sure, because it is something that we're going to use as a test case to then take to other states as well. Because we're going to come across this even when we went to Northern Territory, even in Queensland, some areas, especially when you get into a waterway, not so much with a leaky contour out on country. But good question, and yes, it's a world of pain, is the short answer. Yeah. Victoria's next on our agenda.
Yeah, Chrissy Stewart, Southern Victoria. On our farm, we have a creek line that's 30 metres deep, 40 metres wide up one end, and not as bad coming as it comes out of the property. I've been looking at how we can help to ameliorate that. My parents have done an amazing job with a lot of tree planting all around the creek line, but there's still a lot of erosion going on, active erosion, along the whole creek up in the catchment, as far as I can tell from going and looking at it on people's properties. In terms of if, it takes that long to get regulation, all that sort of thing, to do big works, it's also actually a man-made creek, so we might be able to get around some of the regulations from drainage works that were done many years ago. Is there ways to just go in and do your own little thing? So it's going to be pretty hard for us to get machinery in there because there's a lot of trees all around it.
Yeah.
I've been wondering about, we've got crew that come out and do like family tree planting days. Can we go and have a go at building our own little leaky weirs? Like I was thinking about getting hay bales and stakes and just trying to create things, then planting plants into them with compost in the hay bales to try and create living green weir systems, maybe in the areas that aren't as bad, just to at least start the process. Do you have any recommendations around that? Like, what are things that we can just have a go at?
So number one, I'm going to curtail this with, please check what your regulatory requirements are and whether or not you are in a designated waterway that might cause you problems. I don't want to encourage that anyone should flout the law, especially while I'm standing here officially. But what I would say is always start higher up in the landscape and work your way down. So there's a whole heap of work that you can do even in your local catchment, such as those leaky contours from the ridgeline all the way down. Trap as much water as possible, slow it down, spread it out, infiltrate it, and get that vegetation. Even the local catchment will benefit from that. But the other aspect in terms of your waterways, you'll probably find there's a lot of ephemeral waterways that are leading into that more permanent. Work on them, because even starting there will help. Every little bit counts, because the more that you can support that, then the energy further down in the system is dissipated. And here's probably a key point. Things such as we reduce that flood impact intensity, because if you imagine if we did this at a catchment scale, places like Lismore would never have had the intensity of that flood rushing in at all. We could save townships. That's not to say that they shouldn't still build such infrastructure on a floodplain, because a floodplain still needs to function as a floodplain, but we could have saved a whole heap more hurt and pain. And more or less, what are we going to see for those poor farmers up in the upland, that even after they've had all this rain and it's drained away, they're going to feel like they're back in drought by next year. So how do we actually spread that water around in this landscape? Well, our First Nation people knew how that worked. How can we get that balance between agriculture and environment? Well, actually both can work very well together. In fact, again, the point being is that your environment will actually help support that productivity. We just also got to make sure that one of the other key things is it's all about diversity. Diversity of plants that supports diversity of soil microbia, that actually then really helps generate your production, but also your abilities to store more water.
Thanks, Luke. And sorry to cut you off short. I think a lot of people had questions, so I'm sure you can catch Luke and ask your individual questions throughout the rest of the day. But thank you very much for your presentation.